Okay, it's Jared. I'm doing my physics tree response. Okay, so question 48 looks like this, with a 6-volt battery, 2 resistors here and here, 10 and 20 ohms, and 2 capacitors, 12 and 6 microfarads. So part A just asks to find the total capacitance of the circuit, and you find capacitance by you add capacitors in series like you would add resistors in parallel. So one over the capacitance equals 1 over the first capacitor plus 1 over the second capacitor, which is 1 over 12 plus 1 over 6, which is 3 12s, 12, and then you inverse it, so 12 thirds, which gives you 4 microfarads, or 4 times 10 to the negative 6 farads. Part B asks you to calculate the current in the 10 ohm resistor. The 10 ohm resistor was that one at the top. And so resistance is obviously 10 ohms, voltage would be 6 from the battery, and then current equals voltage over resistance. So you just substitute them in, 6 and 10, to get 0.6 amps. Part C is to calculate the potential difference between points A and B. Potential difference is just voltage. Points A and B are, you can see it, A, B, and the path it takes goes along here, so you're only getting the 20 ohm resistor. So resistance 20 ohms. You need a new current because it's now going through the 20 ohm resistor, not the 10 ohm one. So it would have traveled from 6 up to 10 and to 20. So for the new current, the resistance should be 30 because it went through both the 10 and the 20 to get here. So 6 over 30 gives you 0.2. And now the voltage equals 20 from the resistance times the 0.2 of the current, which gives you 4 volts equals IR. Part D, calculate the charge stored on one plate of the 6 microfarad capacitor. So charge equals capacitance times voltage. We already know the capacitance we found in part A. It was 4 microfarads, 4 times 10 to the negative 6. So 4 times 10 to the negative 6 times the voltage, which is 4 because we just found that there. And that gives you 1.6 times 10 to the negative 5th farads. Point E, the wire is cut at point P. Will the potential difference between points A and B increase, decrease, or remain the same? Okay, I forgot to put point P on here, but it is right here, in the middle between the 2 capacitors. So the potential difference should remain the same because at point P in the middle there, if that's cut, it doesn't actually affect the path it's going from A to B. If you get to A to B, it just goes here, here, and then around. It doesn't actually ever go through here. So it should just remain the same. Question 49. Or I'll take a break here.